Good afternoon, everyone. I'm Ming. Now we are from Group 3, and I want to introduce my group members. They are Teo Hausin, ADRIANA Noor ZAININA binti Noor HISHAM, EFFA AZREEN MOHAMAD, Noor FATIHAH ASYIKIN binti Wan CHIK, Noor HAFIFAH ALIA binti AZMAN, SITI FATIMAH binti AHMAD. So now I would like to invite EFFA to begin our discussion on the product description part. So EFFA, please.
Thank you, Jimmy. As we know, our product is pasteurized reconstituted milk that use full cream milk powder with water and may contain salt and permitted food conditioners, and then subjected to pasteurization as stated in Food Regulation 1985. It differs from other ready-to-drink milk products such as recombined milk and flavored milk. For instance, reconstituted milks provide a lame flavor compared to the flavored milk, but the fat content of reconstituted milks and recombined milk share the same amount of milk fat and non-milk fat solid, which is 3.25% and 8.5% respectively. We use high temperature short time HTST method as a heat treatment to eliminate all vegetative microorganisms uh, and, and inactivate most enzyme, but some endospores bacteria, such as Bacillus species, is resistant to heat treatment and causing spoilage to the product. Therefore, it provides a low shelf life, which is about 10 until 20 days, influenced by storage temperature, compared to the other treatments such as sterilization. However, sterilization process will affect the final taste, such as slightly burnt taste from the Maillard reaction due to the high temperature treatment. So this is why HTST pasteurization is chosen in our project. Is there any question or suggestion for our product description?
I am agree with what you are saying, Eva. However, have you considered about UHT pasteurization because it provides a longer shelf life instead of HTST treatment?
You are absolutely right that UHT treatment can give longer shelf life, but we also must consider the taste and economy when producing our meat product. This is because the major disadvantage of UHT pasteurization is the original flavor of the milk will be altered due to the high temperature treatment. Besides, high temperature usage will lead to the high energy consumption and the average cost will be higher compared to HTST treatment. Is it clear, Housing? If there is no other question, I will pass to Jimmy.
Oh yeah, it is clear to be. Thank you, Eva.
Next, it's Adriana turns to discuss about the food ingredients we use in our milk products. So, Adriana, please.
Sure, thank you, Jimmy. I will discuss the ingredients used in our milk product. The ingredients used are full cream milk powder, water, salt, and permitted food conditioner, which are sodium caseinate and carrageenan. As our friend Effa has mentioned before, reconstituted milk is a milk product, whereas full cream milk powder is added with water. Thus, we include this in our production. Full cream milk powder is used as it can be stored longer and easily standardized. This may help in tackling the shortage of raw milk issues in our industry. The cleanliness and quality of water used also need to be considered to ensure the safety and quality of our end product. Then salt. Overall, salt is added to enhance the solubility and prolong the shelf life of the milk. As milk contains a huge number of casein, which is insoluble in water, the addition of salts, or chemically called as sodium chloride, may help to form loosened casein micelle structures, hence enhancing its solubility in water. This makes the mixing process easier. The addition of food conditioners is generally to emulsify and stabilize our milk product. So in our case, we use sodium caseinate and carrageenan. Sodium caseinate is well known for its amphiphilic structure, thus it can work efficiently in milk, which is an oil in water emulsion. Carrageenan, on the other hand, provides a soft gel network, thus it prevents milk phase separation and improve its mouthfeel taste. So is there any questions on that?
Yes, Adriana. I want to ask, what is the method used to calculate the formulation of the milk product and how much cream milk powder and water will need to be used? That's all.
Okay, thank you, Fatima, for the question. So for the formulation, we use Pearson square method, as we already decided on the mass and fat content of the end product, which is 200 kilogram of milk and 3.25% of milk fat and 8.5% of non-milk fat content. So we use it as our reference point for the calculation. Therefore, we need to use 26.9 kilogram of full cream milk powder and 173 kilogram of water for this product. So am I answering your question, Fatima?
Yes, thank you, Adriana, for your answer.
So thank you, Adriana, and also Fatima. Now I'm going to discuss the process flow. So for the process flow, after previous discussion, I think we will remove the filtration part as suggested by Dr. Tan. This is because it is not necessary to that extent for the production of our milk product in order to save costs. Then for the pasteurization part in our process flow, since there are two types of heating, for pasteurization that are the batch heating and also the continuous heating, in my opinion, I think batch heating will be more suitable for us, and I suggest carrying out batch heating by using a vat. Batch heating is more appropriate than continuous heating because for continuous heating, we need to consider more like the heat flow, flow rate, and many others. So I want to add on that continuous heating using plate heat exchangers will cost more than the vat used in batch heating. I had checked about the batch heating. Batch heating is still used in many countries in the dairy industry. This is the reason why I prefer to use batch heating uh, instead of continuous heating. Next, I would like to add in the shelf life study, which is conducted after storage, as discussed before. I think this is necessary to check for the efficiency of the HDS method decided by us and to ensure our milk is safe to be consumed. So this shelf life study is checked based on several parameters such as pH. I would like to hear any suggestions or opinions for this. So anyone?
Jimmy, is there any specific time to perform the shelf life study, such as a week after production and so on and so forth?
Okay, thank you, EFFA. Yes, there is a specific time to perform the shelf life study, and I think a week time is a good suggestion as it provides enough length of time for any changes to occur in our milk product. Is my answer clear, Effa?
Yes, it is clear. Thank you, Jimmy.
Okay, thank you, Effa. So, okay, good now. Fatima, how about our calculation part?
Yeah, thank you, Jimmy. For the calculation of lethality, we need to choose the target pathogen that needs to be destroyed by pasteurization. The pathogen that we choose is Listeria monocytogenes. It is a foodborne pathogen that has a mortality rate of 20 to 30% worldwide and is one of the most heat-resistant pathogens in milk. So the temperature that we use for our milk product is 73 degrees Celsius for 15 seconds. Any question?
Fatima, I want to ask, why do we need to use 73 degrees Celsius for 15 seconds? And how can we calculate the lethality value? And for the code value, what is the indicator that we are going to use?
Thank you, HAFIFAH. The duration for pasteurization process, which is 15 seconds, we got from the Food Regulations 1983 for the HTST method. So, firstly, I need to calculate the lot reduction of Listeria monocytogenes, and the lot reduction must be more than 5, at least 5, because the pasteurization needs at least 5 lot reduction of pathogens for the milk product to be safe to consume. Next for the calculation of lethality, because we don't have the data of the temperature, so just explain how to calculate the lethality value. So firstly, a series of lethality rate will be used to plot a graph of lethality rate against time, and then the area under the curve will be calculated by multiplying the lethality rate and the time interval between them. The summation of the area under the curve is the total lethality value that is needed to destroy pathogens in milk product. Lastly, the lethality value, we need to compare with the 15 second. If the lethality value is the same as the 15 second, it means that the holding time is adequate to destroy the target pathogen. And for the code value, I think it is best to choose thiamine as the reference attribute for the quality value.
Okay, I see. But then I want to ask, why do we choose thiamine?
The reason why is because thiamine or vitamin B1 is a thermal vitamin, and it is an important vitamin in milk. Milk is one of the sources of thiamine for humans, and so we have to calculate the impact on the quality of a given thermal process, which is 73 degrees Celsius. Is
See,
it okay,
thank
Hafifa?
you. Yes, yes. Thank you. I understand now, Fatima. Thank you.
Okay. Okay, well, after this, I would like to discuss the package and storage. Please, Hafifa.
Yes, for packaging and storage, I think I will do like a comparison between plastic bottles and glasses. Then based on that, I will talk about why we are choosing plastic bottles rather than choosing glasses. Is it okay?
Yes, but for the packaging materials, I suggest to include laminated boxes also in the comparison. This is because laminated box is also one of the most common packaging materials for milk that we can see in the retail markets. Besides, I suggest comparing these packaging materials in a table form so that it is easier to be read. Is it okay to do such a way like this, Hafifa?
Yes, I miss out about the laminated boxes. Yes, I can put it together, and I agree to put it on the table so that it is easier for us to understand and can make direct comparison from the table. Uh, so in the table, I will include certain criteria such as mechanical strength, cost, uh, mechanical strength, cost, weight, and others. And I will compare all these criteria with the packaging material. As for now, I think we can use plastic bottles rather than use other types of packaging. Using plastic bottles is much more convenient compared to laminated boxes and glasses. If we use laminated boxes, we need to provide straw at the packaging, which is not good for sustainable. Also, laminated boxes is not very strong in terms of the mechanical strength. In the other hand, using glasses is quite risky since they are fragile and expensive. Also, consumer need to use bottle opener every time they want to consume the milk, which is not convenient at all. So I think we will use a plastic packaging for our project.
Yeah, I agree with you, Hafifa. Plastic bottles are the most convenient packaging materials compared to the others. So it is the most suitable packaging material for our milk product. And before Fatihah, I would like to make a correction on Fatimah's part that just now he said that the food regulation is 1983, but I would like to amend that that is 1985. So is it clear, Fatimah?
Yes, yes. I misspoke. Okay.
Okay. So now we are going to Fatihah's part. Are there any changes for the safety analysis part? Fatihah?
Yes, Jingming, there are some new changes for the safety analysis part. Before this, we only have one test, but after some reconsideration, I have decided to include three other tests. Since our product is pasteurized reconstituted milk, it is important for us to check for any recontamination of pathogenic organisms after pasteurization. The finalized tests that I have decided are methylene blue reduction test, alkaline phosphatase test, total plate count and coliform count. So any question?
So Fatihah, what is the significance of this test for the milk product? Can you please explain in detail?
Oh, sure, Adriana. So for the first test, we have methylene blue reduction test. So the purpose of this test is to check for the overall microbial load and quality control of our milk product. It works by measuring the time taken for the methylene blue dye to decolorize the milk due to metabolic reaction of bacteria. So the faster the decolorization occurs, the higher the microbial load present in the milk products. So next we have alkaline phosphatase test. So for this test, it is used as an efficiency index for pasteurization to see whether the milk has been adequately pasteurized or it has been contaminated with raw milk after pasteurization. So for the color intensity for properly pasteurized milk, it should give a reading of 10 microgram or less of paranitrophenol per milliliter of milk. The third test is total plate count. Total plate count, the purpose is to determine the bacterial population in our milk product which grow aerobically at mesophilic temperatures. So milk produced under hygienic conditions from healthy cows should not contain more than 50,000 bacteria per milliliter of milk. Lastly, we have coliform count. So for coliform count, the purpose of coliform count is to reduce the number of coliform present in the milk. So coliform are generally present in food that has been fecally or environmentally contaminated. Therefore, coliform count in adequately pasteurized milk should be small and should not exceed 10 coliform per milliliter of milk. I hope that answer your question, Adriana.
Yes, thank you, Fatihah.
Okay, thank you, Fatiha and also Adriana. Then I also agree with those analysis mentioned by Fatiha too. Last but not least, Housin, so far how is our quality analysis part?
Okay, Jimmy. For the quality analysis, there will be several analyses regarding to the quality of the product to be done to ensure the full cream milk produced by us is considered as good quality and is fulfilled the requirement in Food Regulation 1985. First and foremost, organoleptic tests will be carried out to check for the physical quality of the product. Organoleptic tests involve all the perimetric quality tests and is a rapid, simple, and costless method of checking the quality of the milk and allow for segregations of good and poor quality of milk. The milk grader must have a good sense of sight, smells, and touch of to ensure the results obtained are reliable and trustworthy. There will be a list of type of all flavor of the milk that being listed on in our project. Secondly, cloud on boiling test, where is a rapid and simple analysis used to determine the overall quality, especially acidity of the milk. When the pH of the milk is less than 5.8, it will start to coagulate and form lumps or flakes on heating treatments. The milk with lower pH cannot withstand the boiling process and show coagulations along the edge of the milk. Furthermore, the milk with extremely low pH will show serious coagulations and flakes during the boiling process. This phenomena shows that the milk is in poor quality. Next, titratable acidity is used to indirectly measure the extent of bacterial growth of the milk product. The titratable acidity value of the normal milk is about 17 tonus degree, which obtained by titrating 100 ml of the milk with 0.1 unsodium hydroxide. An increased quantity of the alkali required to change the pH of the milk from 6.6 to 8.4 indicate that the acidity or titration value of the milk increased, which may due to the growth of bacteria in the milk. Moreover, heavy metal analysis will be carried out to ensure the dairy product is free from the heavy contaminations and fulfilled to the requirements set in the 14th Schedule Regulation 38. Maximum permitted portions Maximum permitted proportions of metal contaminants in specific food, which is milk and milk product under Food Regulations 1985. In addition, the determinations of milk fat content is crucial in the milk to correctly standardize the milk and to ensure the milk fat content of the milk product is fulfilled to the requirement set in the sub-regulation 2A1. Milk shall contain not less than 3.25% of milk fat of regulation at 2 raw milk or fresh milk under Food Regulation 1985. As similar to the milk fat content, the non-milk fat solid content is also important in the milk product to correctly standardize the milk to ensure the non-fat milk solid content of the milk product is fulfilled to the requirements set in the sub-regulation 2A2. Milk shall contain not less than 8.5% of non-fat milk solid of regulation 82 milk, raw milk or fresh milk under the Food Regulation 1985. A homogenized pasteurized milk should comply with the homogenization test to fulfill the requirement as stated in Regulation 2D. When pasteurized milk is homogenized, it shall comply with the homogenization test of Regulation 85, pasteurized milk under Food Regulation 1985, and to ensure the effectiveness of the homogenizations of milk to prevent creaming, the top and bottom test is selected to determine the homogenization index, and when the index is less than 10%, the homogenization process is considered as efficient. As an example, if the fat content is 3.15% in the top layer and 3.9% in the bottom layer, the homogenization index will be 7.9, which is less than 10%. Is it clear for the quality analysis? Any question from you guys?
Yes, Haojin, I have a question for you. So there are many methods that can be used for homogenization test, but why you choose top and bottom method for our product? Can you explain?
Oh, sure, FATIHAH. This is because this is a simple technique compared to other methods, like using a microscope to determine the average particle or droplet size of the product is so complicated. And this method is also more reliable compared to just looking at the separations of the milk, as the separations may not be seen clearly. Do I clear your doubt on using top and bottom test?
Yes, Haojin, definitely. Thank you.
Okay, so I think there is no other question. Then we will end our discussion for today. Thank you guys for attending this discussion. Goodbye and have a nice rest.
All right, Jimmy, thank you.
Bye bye.
Thank you.
Yeah, thanks to you guys. Thank you.